Hey everyone, and welcome to this explainer. Today, we are taking on a massive, absolutely universal headache in artificial intelligence, and that is making AI do exactly what you tell it to do. Look, going from a really cool local prototype to a rock-solid enterprise app, that's a huge leap. So today, we're diving deep into how to force an LLM to follow your rules, every single time, using Claude's strict tool use. Buckle up because we are about to turn total chaos into precision engineering.
So let's just jump right into it by asking the million-dollar question. Why do AI agents break in production? Honestly, we've all been there. You spend days, maybe weeks, crafting the perfect system prompt. You run it in your test environment and it works beautifully. It's passing arguments, it's hitting your APIs, it's fetching data exactly like it should. But then you deploy it to production and out of nowhere, bam, the entire system just comes crashing to a halt. Why does that happen? Well, it's because underneath all of your complex logic, you're relying on a probabilistic model to output deterministic code. You're basically asking a highly creative text generator to act like a strict software compiler, and eventually, it just goes off script.
Picture this. You're building an AI agent for a flight booking system, right? And your internal function specifically requires the number of passengers to be an integer. Well, without strict constraints, Claude might perfectly understand what the user wants, but it might output the word to spelled out as a string, TWO, instead of the actual number 2. Or maybe it outputs the number 2 but wraps it in quotation marks. To a human reading it, that seems completely harmless, but to your database or your API, that incompatible data type is a fatal error. It literally crashes the system. On the flip side, the type-safe output we actually need for a successful run is just the pure, unquoted integer 2.
Historically, developers have tried to patch this problem through what I like to call the prompt and pray era. You know the drill. You know the AI might spit out incompatible data types or just randomly omit required fields. So what do? You write these massive, bloated system prompts. You're basically begging the AI, saying, please, I am begging you, only output valid JSON, and whatever you do not forget the passengers field. And because you still can't really trust it, you have to write all this heavy validation bloat in your actual application code. You have to parse the output, check the types, and when the AI inevitably hallucinates an extra comma and fails, you trigger these endless retry loops. You're just sending the error back to the AI, essentially asking it to fix its own mistake. Guys, it's expensive, it's painfully slow, and it absolutely does not scale for real enterprise applications.
Okay, so how do we finally escape the prompt and pray era? Enter strict tool use. Setting strict true on a tool definition provides a mathematical guarantee that Claude's tool inputs will match your exact JSON schema. Let me just repeat that because it's a real game changer. It is a mathematical guarantee. We are no longer hoping or praying the model formats its response correctly. We are forcing it to. This completely shifts the entire paradigm away from probabilistic guessing and straight into deterministic type safety.
Now you might be wondering, how on earth does Claude actually guarantee this under the hood? It does it through a technique called grammar-constrained sampling. I know that sounds like a bunch of heavy technical jargon, but it's actually this beautiful piece of precision engineering. Think about it. When Claude generates a response normally, it's just predicting the next token, right? Without constraints, it could pick literally any word in its vocabulary. But with grammar-constrained sampling, the API takes your specific JSON schema and compiles it into a strict, ironclad grammar. During the actual text generation, it physically constrains the model's token sampling. If the next valid character in your JSON schema has to be an integer, the system literally masks out all other tokens. The AI is mathematically blocked from outputting a response that breaks your schema.
Quick side note here, because I want to make sure we clarify the difference between two really complementary features. First, we have JSON outputs, which you handle using the output config format parameter. You use this when you want to constrain the model's entire text response to extract structured data, like, say, pulling contact info out of a messy, unstructured email. Second, we have strict tool use, which is what guarantees those type-safe function arguments for your agentic workflows. And what's really amazing is that you can use these totally independently, or you can actually combine them together in a single API request if your architecture needs both. All right, let's get practical. How do we actually build this thing? The Anthropic documentation lays out a remarkably clean, high-level roadmap. It's really just a 3-step playbook. Step 1, you define your tool schema. Step 2, you add the strict parameter. And step 3, you handle the tool calls. Let's walk through each of these steps so you have a really solid mental model of how to implement this yourself.
So, step 1 is where you create your blueprint. You're going to define a JSON schema for your tool's input schema. And you're just using the standard JSON schema format here. You map out your property names, you set your data types, like string or object, and you explicitly state your required fields. There are just a handful of limitations to keep in mind so it plays nice with the grammar compiler. For example, you absolutely have to set additional properties to false for your objects, which completely stops the model from hallucinating extra fields. And right now, things like numerical constraints or string length limits aren't supported. But even within those bounds, this schema becomes your ironclad contract.
Moving on to step 2. Honestly, this is where the magic happens. You simply set strict true as a top-level property in your tool definition, right alongside the tool's name and description. That's it. That one single Boolean value completely wipes out the need for you to write custom validation scripts or handle complex retry logic in your application code. You flip that switch to true, and the API just takes over all the heavy lifting of enforcing compliance.
And that brings us to step 3, handling the tool call. Because you set up those strict constraints, you now have these massive guarantees when the AI responds. The tool input strictly follows your schema, no exceptions. The tool name is guaranteed to be valid, meaning it's only ever going to call a tool you actually provided to it, not something it's just made up. And the best part? This works seamlessly whether you're using provided tools or server tools. Because you can actually trust these guarantees, your code at this step becomes incredibly lightweight. You literally just take the arguments and pass them directly into your functions.
Now, if you're building on the Gemini Enterprise Agent platform, you're probably wondering what exact infrastructure supports this feature today. Well, you have access to this right now on Claude Opus 4.7, Claude Sonnet 4.6, and Claude Opus 4.6. And as the documentation points out, support is coming very soon for the 4.5 generation of models too, which includes Opus, Sonnet, and Haiku. So you've got a really robust, highly capable lineup ready to handle these strict constraints right out of the gate.
Okay, let's shift gears for a second and talk about under-the-hood architecture and data retention, because understanding this part is absolutely vital for optimizing your apps. Like we talked about earlier, turning a JSON schema into a strict grammar takes compilation. So to optimize for latency and save on compute, the API temporarily caches your compiled tool schemas. That cache sticks around for up to 24 hours since it was last used. But, and this is crucial, your actual prompts and the model's responses are completely separate from that caching mechanism. Those are discarded immediately after the API response is sent back to you.
That separation between cached schemas and message content creates a massive, absolutely crystal clear enterprise boundary, which is huge if you work in healthcare or deal with sensitive data. Strict tool use is HIPAA eligible, but there is a major catch you have to understand. Protected health information, or PHI, is perfectly fine in the message content, meaning your prompts and the AI's responses. That's allowed because those messages are protected under standard HIPAA safeguards and are discarded, not retained. But PHI is strictly forbidden in your tool's schema definitions. Why? Because those schemas are cached for 24 hours, so they don't get those same ephemeral protections. So the golden rule here, never, ever put patient names, sensitive enum values, or private regex patterns into your schema property definitions. Keep the schema generic.
So, zooming out, what is the big takeaway from everything we've covered today? I think it all boils down to this single, incredibly powerful quote: production-ready agents that work consistently at scale. By adopting strict tool use and structured outputs, you aren't just tweaking a prompt. You're fundamentally changing how you build. You're stepping away from the chaotic experimentation of crossing your fingers and begging a model to behave. Instead, you're stepping into the realm of reliable, enterprise-ready software engineering, where data types are fully respected and your functions execute flawlessly. I want to leave you with a lingering thought as you head back to your codebase today. Take a hard look at the architecture you're currently running. Is your AI agent truly production-ready? Or is it just one bad, hallucinated JSON response away from a catastrophic runtime error? If you're still living in the prompt and pray era, it is definitely time to flip that strict Boolean to true. Thanks so much for joining me for this explainer, and happy building.